Today let us start with Poisson distribution. Today let us start with what? Poisson distribution. Anna, you are attending the lecture, right? Okay. You please send your father's number in my mobile number. Please send it to me. Or ask your father to talk to me. Ronaldinho, you too. Yes. Let us start with Poisson distribution. So, discrete distribution is of two types. What are the two discrete distributions we discuss in our syllabus? Binomial and Poisson. I already told you. You may be thinking, why the hell we have to learn two distributions for discrete? Why two people have invented the method? That time I said, there are some limitations in binomial. Okay, to overcome the limitation, that is Poisson overcame with that solution, and he came with the solution for those limitations, and he introduced his own method. That is what? Poisson distribution. What is it called, my dear? Poisson distribution. Is that clear, all of you? Say loudly. Okay. So, Poisson is name of the person. So, what are the conditions for binomial distribution? Can you tell me that what is exactly? Finite. The trials are independent and it is finite. And it is what? Finite. One more limitation also there. One more limitation also there. See, the limitation is nothing but, sir, if the number of trials are finite, I apply Bernoulli or binomial distribution. What exactly the limitation? As a mathematical point of view, people may be asking, what if infinite trials are there? What if infinite trials are there? For finite, binomial is there. So, for infinite, binomial distribution not possible. So, Poisson came up with the solution and he brought the distribution called Poisson distribution. Is that clear, my dear? That is what we call it as Poisson distribution. Is that clear, all of you? That is what we call it as Poisson distribution. Okay? Yes. I told you the limitations. One more limitation I said. Okay? Binomial distribution will not be applicable even for very small success. If the success rate is very small, if the success is very close to zero, binomial distribution not possible, because when the success is very close to zero, the probability I will be getting zero only. If I use binomial distribution, remember one thing, success rate I said very close to zero, but I never said equal to zero. But Poisson, probability what you are getting? Zero we are getting. So, that is a major drawback, my dear. That is the major drawback. Is it clear, all of you? That is the major drawback. Okay. Yes. Now, as I told you, the limitations of binomial distribution. When number of trials infinite. If number of trials is infinite, probability of success is very small. Binomial not possible. Binomial not possible. So, Poisson came up with the solution, and that is what we call it as Poisson distribution. That is what we call it as Poisson distribution. Okay. Now, let me give you one example. Sir, when that probability of success very close to zero. Okay. Now, for example, you are reading any books. For example, ICA material also. ICA material you are going through. There are more than 30-40,000 words will be there, right? There are more than 30-40,000 words will be there. Now, how many mistakes you can find? Very less. Very less. If it is coming from any proper publication, there will be mistake. There will be an error. But the error will be what? Very small. For example, out of 30,000 words, you may find 2-3 mistakes. You may find how many mistakes, my dear? 2-3 mistakes. For example, 3 mistakes you are finding. 3 mistakes you are finding. 3 out of 30,000, which is nothing but 0.00001. Very close to 0, but not equal to 0. Very close to 0, not equal to 0. So, This is actually what, in this case, what we have to use? Poisson distribution. So now, mistakes in these books are very rare, or what, is it right, my dear? The mistakes in the book, what you are finding, is it going to be rare event or not? Rare event or not? Rare means you understand, na? Rarely we can find the mistakes. Okay, rarely we can find out the mistakes. So Poisson distribution, also I am going to call it as probability of rare events. Probability of rare events. I will give you some situations, my dear. That's what I said. Now, number of misprints in the book. It's a rare event only. It's a rare event only. But if I correct your paper, definitely Poisson distribution not applicable. Because it will be having what? Full of mistakes. Correct, na? It will be having what? Full of mistakes. Even my question paper also, what, the people who are typing, to the extent we can go up to rare events. To the extent, because out of 50, not all 50 are mistakes. Now, 2-3 mistakes we find. But still, I am telling you, when it is highly possible, then definitely what? Poisson will not be applicable. Only for rare events, Poisson is applicable. Why rare events? Because when it comes to rare events, probability of success is going to be what? Very close to 0, but not equal to 0. But not equal to 0. Now number of road accidents in this Govindan road will comes into Poisson or binomial? Say loudly. Say loudly. Poisson distribution. Why? Is it every now and then accidents happening or what? Is every now and then happening accidents happening or what? No. This comes under what? Rare event. So this is, in this case, I have to apply what? Poisson distribution to find the probability. The question may be asked, if 10,000 people are crossing this road, okay, what is the probability of having at least 2 accidents? Yeah, at most 2 accidents. If I have to find out this, then of course what I should apply, my dear? Poisson distribution I should apply. When I correct your paper, should I apply Poisson or should I apply binomial or something else? Binomial. Why? You are also confident that a lot of mistakes will be there. Actually, you have to solve, you have to write a paper in such a way that the application of probability should be Poisson. But the way you are writing is binomial. Okay. Actually, it should be what? Poisson, but the way you are writing, binomial. So, next time whenever you come and say, sir, today binomial distribution, sir. Sir, today Poisson distribution, sir. So, we understand. So, Poisson distribution means what? Teacher is going to find the mistake rarely. That is Poisson distribution. Binomial distribution is what? Teacher is going to, yes, he or she can easily find out the mistake. So, next time whenever you write the paper, see, these are small things which when you start discussing about that, the mathematics will become very close to heart. See, day-to-day life example only. Day-to-day life example only. Now, I hope you understood when to apply Poisson and when to apply binomial. So, your CA foundation paper should follow binomial or Poisson? Poisson. But what exactly happening most of the time? Binomial. Okay. Actually what? Binomial. And happening is binomial. But our expectation is what? So, we can have a meme. Only we people can understand if I create some meme the way I am creating nowadays. Okay. If I create a meme, expectation, Poisson distribution, reality, binomial distribution. Am I right, my dear? Expectation, Poisson distribution, CA foundation exam results, expectation, Poisson distribution, but reality is what? Binomial distribution. Then, sir, CA foundation results comes under final results. I am talking about CA final results, or that is CAs, number of CAs becoming number of chartered accountants, right? In your batch, is it going to follow binomial or Poisson? Say loudly, man. See, for example, you registered in some particular year, you registered. In particular year, you registered. Across India, more than 70,000 people registered with you. More than 70,000 people with you. Now they are becoming chartered accountants in every single attempt. In single attempt, they are going to become a chartered accountant. In 4.5 years, they are becoming chartered accountant. Now tell me the distribution should be Poisson or binomial? So can we call CA result or becoming a CA is a rare event? Say yes or no? This is Poisson distribution. You understand? See, this is logically what what we are applying, examination we are doing. It is actually what Poisson distribution only. It's a probability of rare events. Probability of rare events. When you take only foundation, it is binomial distribution. When you take foundation, it is binomial distribution. But when you take final, most of the time it is what? Poisson distribution. Most of the time it is what? Poisson distribution. See, just to relate your CA with the Poisson, I given this example, but don't take it in other way around. Don't get demotivated. Oh, how difficult? No. Just to relate. Now you will not forget this, right? Poisson, the difference between Poisson and binomial. That's it. Okay. So number of road accidents definitely comes under what? Poisson distribution. Now, sir, this is okay, sir. Why should I find out these things? For example, insurance companies use this, na man, because they are claim now. That is, insurance companies, accidents, based on accidents, they have to pay the claim whatever amount. Okay, they have to release the amount. Okay, they have to release the amount. We can claim the amount what we given, what we paid. Off pannunga correct. Adha enna kaadu or mari vein irukken paathukken. So they need, okay, they need these type of calculations. They need these type of calculations. That is point number 1. Now, air crashes comes under binomial or Poisson. Any technical issues in air, that is flights, is it comes under binomial or Poisson? So, actually what you know, as I told you every time, you cannot give any certainty to anything. No sir, this will happen sir. No, flight will definitely will reach. No, whenever I board the flight, 99% I believe it will reach the destination. But at least there is a 1%, yes, of course, whenever we travel, anything. But actually what you know, as compared to train, as compared to road, air is what? Safe. But if accident happens, there is a chance of surviving in road and train accidents. There is no chance of surviving in air crash. Okay, that risk we have to take. Okay, that risk we have to take. Okay, fine. Whenever I book the flight ticket, there is willing you to take the risk, or you want to insure. That option will come. Okay, will you take the risk, or you would like to insure the travel? Every time I book the flight ticket, it comes. Okay, because everyone knows there is a risk in traveling. There is a risk in traveling. Let it be. So risk everywhere. Without risk, no, nothing is possible. But we are coming every day. We are coming and going. That comes under probability of rare event. But it is not a sure event. Definitely it is not a sure event. Am I right, my dear? Definitely it is not a sure event. Definitely it is not a certain event. It comes under what? Rare event. What about your result? Comes under rare event. That is binomial or Poisson? Your results are binomial, because there is equal chance of clearing the paper. I was talking about the final result, the percentage for CA final. That is rare event, but not this. This is not rare event. This comes under binomial distribution. Let me give you one more example where majorly we are applying this Poisson distribution. My dear, I am putting these many. I am giving these many examples only to create some interest. Otherwise, now I strongly believe if you don't know why you are doing these topics only for marks oriented, if you do this topic, you will never understand. If you know, oh, the purpose is good, yes, because of this only I should learn, then it is correct. Okay, that is what I am trying my level best to give day-to-day life example when I do statistics, even in mathematics. Let me give you one beautiful example now for Poisson distribution. Now, any medicines, any new medicines are coming out, like, you know, for example, crozin or saridon, whatever came, okay, now it's a famous medicine across any medical shop you go, without prescription we can get those medicines. Am I right, my dear? But there are some medicines they don't give without prescriptions. There are some medicines they don't give without prescription. But crozin, saridon and all, what happens, my dear? Crozin, Dolo 650 or P70, what is it? Paracetamol, okay, whatever. These medicines and all without prescription we used to get. But remember, my dear, the paracetamol, whatever, the medicine, the moment they invented, moment they produced those medicines, okay, immediately it came into the market? No. I strongly believe the medicine, when it comes out now, at least any medicine should take minimum 5 to 10 years. Okay, it cannot come immediately. It should not come immediately, because that 10 years first they found the combination. It has to be tested with rats, and there is long, we have to wait for very long period whether there is any side effects are coming or not. and after that what, slowly monkeys, dogs, etc. Then finally it come to human beings. Again we have to wait for another 1 or 2 years. If there is any side effect is coming in that tablet or not, that we need to analyze. Am I right, my dear? Say yes or no. This is the process. But we never followed this process in COVID. We never followed this process in COVID. The COVID, actually I was not against of that injection. Okay, I was not against of that injection. But my belief, but I put, because it is mandatory, so I have to do, because that time I used to travel a lot. So by travel by flight, they ask for what? COVID certificate. So I have to inject myself. And the schools also, they made it mandatory. So my daughters also made. But my only concern was what, you know, COVID 2019, 2020 period it started. 2020 December, vaccination out. In 6 months time, how a vaccination can come? Who tested that vaccines? You understand, my dear? So these are the problems, because it comes under actually what, you know, poison distribution. It comes under actually poison distribution. We have to test whether the poison distribution applied properly, the probability rare event checked properly, some mathematical calculation has to be done. So there is no side effects. Whether there is any proof, we don't know. What if that is today, that is 2020 we injected. So now after 20 years what will happen? After 10 years what will happen? No one knows. Okay, no one knows it, because we have injected it, but we don't know what is going to happen. So now what happens? Now our body, that is immune system, we need to build. That is the only criteria now. So now we have to build our immune system properly. That's it. Correct, na? So because see, our body has got immune system that will fight with those viruses, and of course it will eradicate. But still, now our body is fighting with each and every, that is whoever just injected, now everyone. I am telling you, our body is fighting. Okay, that immune system is fighting with those viruses. But we believe nothing should happen. That is the reason government themselves gave that. But of course, it's a huge money involved. No? Thousands of crores of rupees involved in this industry. So these are small things, my dear. See, for example, medicines. Why I was talking about the medicine, Crozin, Saridan and all I was talking now. It comes in the market, right? But at least 10 to 15 years it takes to come to market. Okay, now here Crozin, Saridan. Now tell me, I hope everyone using Crozin, Saridan. Almost everyone using paracetamol, right? Almost everyone. Crozin, Saridan and all what? Paracetamol only. Paracetamol only. That chemical name is what? Paracetamol. But now what we do? Like you know, our company, Crozin company making that paracetamol, and P650 making that paracetamol. Yeah, Saridan making that paracetamol. Okay, that's a combination. The chemical combinations are same. Only the companies are different. Chemical combinations are what? Same only. So whatever paracetamol, that is whatever Crozin, the chemical combinations are there, same combination only what? Saridan. Crozin, Saridan, everything is paracetamol only. Am I right, my dear? Now, why it comes under poison distribution, I'll tell you. Side effects. Probability of side effects. Now, probability of side effects in these medicines should follow binomial or poison. Say loudly. Do you agree with me? Okay, do you agree with me? We believe that, sir, it should come 0, sir. But definitely 0 not possible. At least any one will get affected. Any one will get affected. My daughter got affected because of that paracetamol. Okay, when she was young, now also she is young. I am younger than her. Okay, see, when she was 5 years old, due fever, paracetamol, side effect. You won't believe 4 days she did not get up only. So I admitted in Kanchi Sankaracharya Hospital, the child specialist hospital, child trust hospital. They are only admitted around 11 to 12 days. She was there in ICU. Okay, it was a dangerous time. It was dangerous time. I will never forget that period, that 11-12 days. It is only because of what? Paracetamol. There was a side effect. Okay, liver affected, organs got affected, liver affected, and kidney both got affected. Doctor suggested for dialysis. By God's grace, nothing happened. She recovered because of the immune system what we have. Because our body fights so many times. Okay, our body fights so many times. Okay, so now listen here, my dear. So this, whenever the medicine is coming out, it comes under what? Actually, that rare event. It should be rare event. The side effect should be what? Rare event. If there is definite side effect will happen, then it will not available in the market. Definite side effect happens means what? It will not available in the market. Do you all agree with me, my dear? So here we need to test poison distribution. So now tell me, what is the other name of poison distribution is? Probability of rare events. Probability of rare events. Now let me talk about the limitation. What is the limitation? Trial must be infinite. Look at this. The limitation is, how to read it? N tends to infinity. What is the n tends to infinity? Number of trials. N stands for number of trials. N stands for number of trials. When number of trials approaches to infinity. Condition. Okay, this is the condition for Poisson. This is the condition. N tends to infinity. P tends to what? 0. My dear, please understand, there is lot of difference between P tends to 0 and P is equal to 0. The meaning of P tends to 0 is P not equal to 0. It is P approaching to 0. Please understand, P approaching to 0 but not equal to 0. P approaching to 0 but not equal to 0. So n tends to infinity, and after the word P tends to 0. N tends to infinity and P tends to 0. Am I right, my dear? Say yes or no? Say loudly. Yes, now, what is NP is finite. Mean should be finite. See, N is infinite, but NP should be what? Finite. This is the limitation and this is the condition for Poisson distribution. So in this case, if these cases are applicable in discrete distribution, binomial cannot be used. We have to shift ourselves to Poisson distribution. Are you getting my point, my dear? N approaches to, that is, number of trial must be infinite. Probability of success very small. And what is NP should be finite. Now, can anyone tell me, if N approaches to 0, Q will be what? Q will be approaching to 1. Q will be approaching to 1. Why? If probability of success is very close to 0, probability of failure must be close to 1 only, na? 1 minus P, opposite. 1 minus P, ma. For example, probability of success is 0.00002. Now what is Q? 0.9998. So 9998 is what? 0.998, very close to 1. 0.0002 is what? Very close to 0. So Q tends approaches to 1 actually. So, but there is no Q, that's what I am not using it. So N approaches to infinity, P approaches to 0, and NP is what? Finite, and Q approaches to 1. Say loudly, man. Yes. What is this Poisson distribution is? It is discrete distribution. Am I right, my dear? Random variable, what we are using? We are using random variable, which is nothing but x. Am I right, my dear? The random variable, what we are using? X. X belongs to, definitely must be a whole number. Definitely here x must be what? Whole number again. That means, see, discrete distribution means random variable can be any integer, I said. Random variable can be any integer, I said. But for Poisson and binomial, it has to be what? Whole number. It can be 0, it can be 1, it can be 2, but it cannot be -1, -2 and all. So, random variable x belongs to whole number. Am I right, my dear? Say yes or no? Okay. Since it's a discrete distribution, what function we are going to use? Mass function. What is it? Probability mass function. Am I right, my dear? Probability mass function. Since it is discrete distribution, see, I have told you already about these things, okay? So, since it is discrete distribution, what function will be applicable, my dear? Probability of mass function. So, what is probability of mass function? In short, see, no need to don't worry about that P of x is equal to x. No, sir, what is P of x is equal to x, sir? Please don't worry about those things. It is just P of A, P of B, P of C. Okay, why I am writing P of x is equal to x now? I will tell you. When I write P of x is less than or equal to 1, what are the values of x? X can be 0 or x can be, I am writing like this, na? Because of that reason only I am writing P of x is equal to x. So, don't get confused with the way I am writing it. Oi, I am not doing binomial, it is Poisson. E power minus m, m power x divided by x factorial. What is it? E power minus m, m power x divided by x factorial. In your school level, you might be learnt e power minus lambda, lambda power x by x factorial. Okay, e power minus lambda, lambda power x divided by x factorial. Here I am using what? Yes. Now listen here, what is E? You know, E is a constant. What is E is? Constant. The value of E also defined actually. E is equal to 2.71828. Okay. Now, what is the value of e power minus 1? Tell me, my dear. 1 by? Yes, tell me, what is it? 0.3678. Correct? 3678 or 79? So let me take it as 0.3679. Can you tell me what is e power minus 2? Square this 0.3679. 0.0163? Oh, sorry. 0.53. E power minus 3, 0.0169. 0.01? Okay, 83. Okay, enough. E power minus 4? 0.00? 33. No, I don't think you are right. What you did? E power minus 4, I don't think you are right. Huh? 0.0? Ah, that's it. Is 0 e power minus 4, na? Chal, e power minus 2 is what? Hey, just square it, man. 0.3679 into equal to 0.13 into 0.3679 you do. 0.049. Okay. Next step. 0.0183. Correct. Sir, why you are going up to this, sir? E power minus 5 also can be found out, e power minus 6 also can be found out. 99% of the cases, e power value will be given in the question only. The e power value will be given in the question only 99% of the cases. Let me keep some contingency. If not given, how to find out only I taught you. E value you should remember. E value if you remember, e power minus 1 you know how to find out reciprocal of that. E power minus 2 you know how to find out reciprocal into equal to, then into that same number. So it goes on like that, right? I think you can find out now. Is that right, my dear? Yes. Actually, E is a constant. What is it? E is a constant. X is what? Variable, random variable. What is X is? Random variable. So definitely what? There must be some parameter. What is parameter here? This is what our parameter. You remember in binomial distribution we had parameters, fixed values. What are they? N and P. So here M is what? Parameter. What is M is? Parameter. Now what is X is? Random variable. E is a number. Instead of writing 2.71828, I am writing it as E. Now tell me, my dear, how many parameters we have got for a Poisson distribution? Say loudly. So can we say uniparametric? Can we say it is uniparametric? Can we say uniparametric it is? Binomial distribution was? And this is? Difference. Okay. Binomial distribution when n tends to infinity, binomial not applicable. Poisson is applicable. You understand, my dear? So it is uniparametric. Okay, it is uniparametric. Actually, M is nothing but mean, my dear, expected value only. M is nothing but mean only, expected value. Most of the time it will be given. Most of the time it will be given. Okay. Okay, fine. Are you all ready now? Now, mean of a binomial distribution is NP, that is M only. Variance also M only. So, tell me my dear, in Poisson distribution, mean is equal to variance. Binomial distribution is what? Mean is strictly greater than variance. But when it comes to Poisson distribution, what is it, my dear? Mean is equal to variance. What is mean is equal to variance? Very important MCQ. Very, very important MCQ. In which discrete distribution, mean will be equal to variance? In which distribution? Poisson distribution. What is it, my dear? Poisson distribution. I hope you know what is standard deviation is. Root m. See, as far as binomial distribution is concerned, it can be symmetric. I hope you remember bell-shaped curve. It can be symmetric. It can be skewed, positively skewed or negatively skewed. But whereas Poisson distribution is strictly positively skewed. Probability of success must be less than at least 0.1. So, what exactly Poisson distribution is going to be? Am I right, my dear? Is this what positively skewed? This is what? Positively skewed. I hope you understand the meaning of skewness. Last lecture we discussed. When it is not symmetric, there will be a skewness. That skewness can be positive skewness also will be there, negative skewness also there. Am I right, my dear? See, for example, see, when this positive skewness, when this negative skewness and all happens, I'll tell you. Yesterday there was a rain, right? Yesterday there was rain. Around 10:30s, actually, in general what happens, traffic used to be very less during that particular time. Around 9:30, 10 and all, traffic used to be very less. Okay, less number of people come out, okay. But because of yesterday's rain, what happened, you know, at 10 o'clock, 10:30, there was huge traffic. Correct? 10, 10:30 and all, huge traffic. It is rare event or not? It is rare event. Now, in this case, what happens? Suddenly, when the rain starts, it was normal, 9:30 around, traffic was normal. When rain started and around 10 o'clock, it reached peak. The traffic reached peak, suddenly it raised. Then slowly what happens? Reduced. As rain stops and the traffic reduces. Now in this case, actually generally how it used to happen? 5 o'clock, 6 o'clock and all, slowly it reaches peak time, peak hour, then again it will reduce. This is what normal situation. But yesterday's situation was what, you know, due to the rain, swing. Okay, direct peak, it went directly to peak, then slow drop. It was abnormal event, rare event. In this case, it is what? Positively skewed. It is what? Positively skewed. It is what? Positively skewed. For example, around 11 o'clock there is a rain. Let me see. Around 11 o'clock there is a rain. I'm giving you one situation. 11 o'clock there is a rain. So 10 o'clock and all, what happens? Normal traffic only. Slowly what, you know, rain starts automatically. Instead of talking about this thing, you know, I think you can easily relate to this now. Superb example. Instead of traffic and all, you forget about traffic. Let me go to any online order, Zomato, Zepto and all you are doing now, or Ola, Uber you are booking. You just see that around 9 o'clock and all, it is very less because customers, they will be getting less. So charges also will be less and the traffic won't be there. Therefore, charges will be less. For example, from my place to here, if I have to travel, if I am traveling around 9:30 in the night, 9:30, 10 o'clock, I may get it for what? Even 300 rupees, 320 rupees, I can reach here. 300, 320 rupees, I can reach here by taxi. But there is a rain, demand is increasing. When demand increases, what happens, you know, slowly the rates will be slowly increases, and maximum demand when it comes now, it reaches the peak. Then again demand reduces, it will come down. So this is also skewness, this is also skewness. Am I right, my dear? See, most of the time we commit one mistake that you should avoid. When you book Ola, for example, if your father is booking the cab, and father is not getting, okay, the cab he is not getting, immediately he will ask you to book, you book the cab. You also try. Not asking you to book, actually father will try, will say, you also try, book the cab. And father will say to your mother also, you also try. And your sister also, or brother, you also try. You all four will try. Because of that, what happens? See, system doesn't know one same family is approaching, okay, checking the cab. No, system will not come to know. System, according to system, 4 people are trying. So demand is more. Let us increase the rate. You understand the situation, my dear? Demand is more. 4 people are trying. See, in your house only 4 people. Other place, 7, 8 people are there. 10 people are there. So around, for example, from the same area, in your area, around 12, 13 people are trying. But only 4 cars are available in that area. Only how many cars are available in that area? 4 cars are available in that area. So how many of them are trying? 10, 12 people. Now bidding starts. You understand the system? Do you understand the system? So don't try every time. And you yourself, in this case, this is what skewness. This is what actually skewness. It's, see, sudden hike is there. Now, for example, same destination you will be putting 140 rupees. And same family, for example, Beolin also is from same family, she is also putting the same destination, it will be showing 170. What an, for me 30 rupees more, you only try, for you only 40, book. What is this? Actually they are bidding with you. And some other person will be getting it for 110 rupees. Okay, finally, whoever, maximum amount, they will get the cab. So, if Beolin might have tried, I think she might have got the cab for 170 rupees. Kasturiya did not get. See, this is what actually, see, in this case, whatever, this is skewness. In this case, what should I apply? Skewness concept I can apply. There is one more concept, cortesis. You will never think, these things, wherever and all we are applying. Mathematically, if you know these calculations, obviously when you book the cab or when you book the this thing, whatever online thing you are booking, obviously what happens, my dear, you can reduce the cost. You should apply your mind. During rainy season, Zepto not supposed to order. During rainy season, Zomato not supposed to order. Actually, they charge for rainy season. Okay, rain because the delivery person has to come in rain, so therefore he has to get some extra charges. That is what they will say. That is what they will say. But it is wrong statement. He doesn't bother what his person is doing there. He doesn't bother whether it is sunny day or rainy day. For him, everything is same. In spite of that, why he is charging more? Because during rainy time, in normal time, normal period, 4 people are ordering from that particular area. During rainy time, what happens? That 4 will become 10, 15. So obviously what demand is more. He can collect whatever money he wants. Okay, whatever. So normal period, normal time, whenever you book, you will get it at the exact cost. But abnormal time, whatever you do, you are screwed. Those things are rare events. So most of the corporate companies, everyone is what, earning because of these conditions only. Because of this condition only they earn more. Okay, fine, let it be. So I hope you understand the meaning of positively skewed. I hope you can relate everything with your day-to-day life also. So wherever you go, see, Poisson distribution every time you are applying. Binomial distribution every time you are applying. Skewness you are applying every time, but without knowing. Without knowing we are applying it. When you see your blood report, actually you are applying correlation. Actually you are applying what? Correlation. If I take last 5 years data of my blood report and I am checking it, I am using regression and I can predict what exactly can happen. So what doctors are doing actually? They know the numbers. In medicine, see, initial days and all, doctors used to go for pulses, right? They will check the pulse and based on that, they used to heal. Okay, now we don't believe those things. Actually, it's a mechanical shop only. If you ask me, doctors, clinic or hospitals, everything is what, Human mechanical shop. Human mechanical shop. We enter and we check ourselves if our engine parts and all everything is working properly or not. So there is a machine, it will check. Okay, your heart is proper, ECG. Okay, your liver is proper, everything is proper. Okay, there is a problem with your kidney. So we have to diagnose it. And for diagnosis also there is a machine. To identify that, who will identify? Who will vouch that? The doctor. Because of that, because machines are giving the numbers. Machines are giving the numbers. Doctor knows whether these points, whatever the points which is given, this relation point, correlation points, everything is proper or not. Then according to what happens? He gives the chemical combinations. That is medicine. So if you ask me properly, if you ask me, it's a mechanical shop only. Doctors also like mechanics. Doctors also like mechanics. Only thing is what is the difference between the car mechanic and doctors? Doctors are like, mechanics of human beings and it has got lives. But car mechanics, non-living things. They are the mechanics of living things. They are the mechanics of non-living things. Is that right, my dear? See, every data they are using now, fully based on statistics. If a doctor is a very good statistician, of course, he doesn't require those data. Actually, he has to be a statistician. So he is not able to do it. That's what he is keeping some assistant labs and all there, na? Ortho labs and labs. They are just producing last 5 years data. They are checking and they are giving the results. Programs, everything comes under program now. See, each and every movement, what we are having, everything is based on what? Statistics only. But we don't know. Even your audit report in CA, what you are going to do in future, based on what? Statistical data only. As an auditor, what they will ask, for example, if he find any error in this yearbook, then he will be asked for last 5 years data. Bring last 5 year income report, everything you bring. I would like to check that also. Because here this much error. What was last time? What was last time? Actually, you are going to take the data and you are going to check it. Is that right? So please understand. So everywhere you are applying it. Some of the other way we are applying it. Even the audit reports, everything we are bringing now. For example, thousands of bills to be scrutinized. Thousands of bills to be scrutinized. For example, if some person is coming and audit, you are going for audit, right? You are going for audit and you have to check the transaction. Okay. Is an auditor is going to check each and every transaction? He will say, randomly you select 10 transactions, you check that. If there is any mistake you find, then go for 100 transactions. You'll keep on increase that. So it is nothing but the entire transactions called the population. From that you will select 10. That is sample. You will find whether mistakes are there. If you find any mistake, then you will increase the sample size. You will increase the sample size. What is this? This is not this probability. Sorry, this is not the statistics. Sample and the population. This is actually we think it's a general routine thing only, sir. This is what statistics is. Without knowing what exactly we are doing, we generally apply it. So in your day-to-day life, you are going to do it. Being a chartered accountant, being a doctor, everyone using this. Okay, everyone, data plays very important role. Wherever there is a data, statistics comes. So you are going to play with the data or not? Your entire job is based on the data or not? Say yes or no, my dear. Your decision making is going to be based on data or not? Statistics. Doctors report whatever it comes, it's based on data or not? Statistics. If there is long ailment problems are there, so you have to go for observation. Every 6 months you have to go and approach doctor. Okay, he will study what is last year, last to last year, everything he will study. Based on that only, he will increase the medicine, whatever tablets and all to be increased or not, he will decide it. Is that clear, my dear? So please understand one thing. I took long time for this Poisson distribution. Not for Poisson, it is for entire statistics. That's it. Okay. So these points are for MCQs. These points are for what? MCQs. Okay. Now tell me, my dear, what is it? Poisson distribution is a discrete distribution. What is limitation condition? N tends to infinity, P tends to 0, NP is finite. NP is finite. Since it's a discrete distribution, what is it? Probability mass function. What is probability mass function is? E power minus m power x divided by x factorial. Correct? E value also given 2.71828. E value also given 2.71828. That's it. Okay. Now listen here. M is parameter. So it is uniparametric. What is it? Uniparametric. Now Poisson distribution is what? Strictly positively skewed. I hope you understand this, my dear. Shall we start with the This thing, my dear, questions, MCQs. Hope all you copied. Are you ready to answer MCQs, theory MCQs? Poisson, bimodal, unimodal, both, like binomial only. Binomial and Poisson are same only. Since it's a valid question, let me note that also. Poisson distribution is unimodal or bimodal, not both. You know when it is unimodal, when it is bimodal. That is like, when that is mode is nothing but just m only. Mean and mode are same. Mode is nothing but m only. If m is integer, two modes. If m is integer, then there are two modes, m minus 1. No sound. If m is that Netflix அதெல்லாம் வந்ததுக்கு அப்புறம் நிறைய வெப் சீரிஸ் பார்த்து பார்த்து வான் சொன்ன ஏதாவது ஜாம்பி தான் வெளில வருதா நம்மகிட்ட ஏதாவது ரெண்டு ப்ராப்ளத்தில் வர மாதிரி இருக்குது. நான் இன்டிஜர் then there is only one mode. Anna, are you there in the class? Anna, are you there in the class? Anna Sikandar, are you there in the class? Those who are attending the lectures, can you raise your hand? Gauri, can you raise your hand? Dhanvandi. So only these many people are attending the lectures. Dhanvanti, Gauri, Ronaldino, Uzma, Ilamati, Shakti, Parvadavardhini, Nuha. That's it. So, but many people joined. So, this is what happening most of the time. I know it, this is what happens every time. But I don't want to waste my time in this. But the problem is what, the parents are having a lot of expectation on these kids. There are many students who are attending, for namesake they are entering, so that sir will not call their parents, office will not call their parents, and I am attending the lectures to show that they are doing it. But I don't know. I don't want to do this, but not fair. We are not bothered about your parents also, man, that is. Ronaldinho also not attending, it seems. Ronaldinho is there in the lecture, but not raising his hand. Oh, very good. Hannah is there in the lecture, not raising her hand. So Hannah is not there in the lecture. Only myself and Hannah is not attending the lecture because we both only did not raise the hand. Correct, na? So rest all of them raise their hand. Fine. Drop your hands, my dear. Okay, let us start. Are you ready to answer the questions, my dear? You will enjoy, my dear. You will enjoy. Super duper enjoyment. Don't worry. Now, I hope you understand what exactly I spoke about the Poisson distribution, right? Now, let us start. Which one is uniparametric? Binomial, Poisson, normal, hypergeometric? Poisson. For a Poisson distribution, mean and variance are equal. Option B. Poisson distribution may be A or B, unimodal or bimodal. Poisson distribution is always positively skewed. Am I right, my dear? I told you with the examples, everything, okay? Now, a binomial distribution with parameters n and p can be approximated by a Poisson distribution with parameters m equal to np is, what exactly the option is? N tends to infinity, p tends to 0, so that np is finite. So what is the option, my dear? Option D. Poisson fitting and all not needed. Now, shall we start with the numericals? Now, look at this. Sum number 9, set B. If the standard deviation of a Poisson variate is 2, what is probability of x between 1.5 and 2.9? Listen here. What exactly given? Standard deviation is 2. Can we say root m is equal to 2? Can we say root m is equal to 2? Say yes or no? So what is m equal to? Is it clear, my dear? M is equal to 4. What is Poisson distribution? Probability mass function is e power minus m, m power x divided by x factorial. M we got. Now what is needed? X. We need to find out x. For that, what is given? Probability of x is between 1.5 to 2.9. Wait, I told you very much clearly Poisson variate. Poisson variate. Poisson variate. That is that random variable. See, the random variable I am using it, binomial means I call it as binomial variate. Random variable, if I am using it for Poisson, then I call it as Poisson variate. Now, Poisson variate, I told you clearly it should be an whole number. Did you understand? Poisson variate should be an whole number. Here x is between 1.5 and 2.9. What is the whole number? 2. Which number is between 1.5 and 2.9? Only 2 is between 1.5 and 2.9. See, there are infinite numbers between 1.5 and 2.9. But what is the whole number here? 2. What is the whole number? 2. Can we say it is P of 2? They ask you to find out P of 2, my dear. So what is the formula? E power minus m, m power 2 divided by 2 factorial. E power minus 4 value already got it, 0.0183 into 16 divided by 4. What is the answer? Point? Yeah, Mati pottinga. Nanda potana. Okay, okay. Sorry. 0 point. Okay. Yes. What is the option? Where it is? Ninth sum. Look at this. I will tell you one more thing also. Since it is, see, options are, look at the options. How many digits are there? After the decimal, how many digits are there? Say loudly. Instead of using 4 digits for E value, use it only 3 digits after decimal. Did you get exact answer? See, I am not saying you are not supposed to get like this, but how to decide the number of digits? Based on this, you can decide the number of digits. See, you got 1.146, approximately 0.144, mark and come, nothing wrong. But I am telling you, in the classroom I am teaching, sir, options are having 3 digits. So after the decimal, let me also take only 3 digits based on the result. Not only for this, apply this in index number also. Most of the students are committing mistakes in index number, because I'll tell you, I took it an opportunity to explain this, because last December attempt, one table was given, 3 questions based on the table. Find the last price, find the Paches, find the Fishers. Can you believe the options? 99.72, 99.73, 99.74, 99.75. Now, you get 99.73. But remember, around 7-8 digits are there. You are screwed. So what we have to do, whenever you take, the calculation should be very much precise. After decimal, only 2 digits we have to take, and based on that only calculation should happen. Then only you will get the exact answer. You got my point? So these type of mistakes, of course, last time students know how to use last price. They know how to find the Fishers. But because of this, most of the students lost 3 marks. How many students? There is many students lost 3 marks. Please understand. Okay, fine. Next. Where it is? If see, it is clearly given Poisson variate. So Poisson distribution is given. In this case also what? Mean of a Poisson variable x is 1. Mean of a Poisson variable x is 1. Then what is P of x? At least 1. Look at this. See how simple, this Poisson distribution. What a simple questions. Look at this. Is mean is equal to 1? Say yes or no. Mean 1 or what? What is given? 1, 1. Okay, mean is equal to 1. It is given. Now, probability of x is at least 1, right? You know the meaning of at least 1. What is it? You know the formula. What is 1 minus probability of? The meaning of probability of none is what? 0. X is nothing but 0. I think you got all the values. 1 minus e power minus 1, 1 power 0 by 0 factorial. Please tell me. 0.632. So, 1 minus 0 point. Wait, I know. E value, e power minus 1 is 0.3679. 0.3679. But here what you are going to take? 368 you are going to take. Why? Instead of taking 4 digits, you take only 3 digits. Why I am taking 3 digits? Options are in terms of 3 digits only. Options are in terms of 3 digits only. I think you got the answer. 0 point. Very, very good. Eleventh sum, market, my dear. Very, very important. I think 11th sum also what look at this. Point decimal, 3 decimals, right? After decimal 3 digits, right? Now, x, P of m, the meaning is x is a Poisson variate. The meaning is what? X is what? Poisson variate. And its coefficient of variation is 50. What is the probability x would assume only non-zero values? Look at this. In this question, they did not mention Poisson or binomial. Am I right? They have mentioned. Where they mentioned? X is Poisson variate is given. Okay? X is Poisson variate is given. I think you know. What is coefficient of variation formula? Since it is Poisson variate, standard deviation is root m. Is equal to what? 50. Am I right, my dear? Say yes or no? Is it root m by m is equal to 1 by 2? Squaring on both sides. M by m square equal to 1 by 4. Is 1 by m equal to 1 by 4? What is m equal to? Now, non-zero values, right? What is mean by that? P of x is? What is P of x is? What is P of x is? What is about x? Non-zero values, they said we need to find out the probability of non-zero values. What is my non-zero value? It should be greater than or equal to 1. It should be greater than or equal to 1. Non-zero value means, is it nothing but 1 minus by x is non-zero value means what? X is equal to what? 0. Find. What is the answer? Have you all got the answer, my dear? Now you tell me how you are finding Poisson. Easy only, na? Now look at this. This one you are going to do. If 1.5% of items produced by a manufacturing units are known to be defective. 1.5% item are known to be defective. What is the probability that sample of 200 items would contain no defective item? What is the probability that sample of 200 items would contain no defective item? Now let me tell you one thing, my dear, very important thing. In this question, nothing is mentioned whether it is probability of Poisson distribution or binomial. How you are going to identify? There are two ways of identifying. As a mathematical approach, statistical approach, sir, 1.5% is success rate, sir. It's very slow, very low, sir. Defective item probability is only 1.5. 1.5 means the probability of defective is very small. Too small. Is that right, my dear? Too small. So Poisson will be applicable. This is what the way people approach us. But ultra legends, how they approach, I'll tell you. Ultra legend, how they approach. In the question, e power minus 3 value will be given to you. In the question, in the bracket now, e power minus 3, bracket about e power minus 3 value is equal to, will be given in the question itself. By looking at it, what you will decide, sir, this is Poisson distribution. This is ultra legend method. Okay, but normal people, worst people, by reading the question, 1.5%, what nonsense, man. In the exam, definitely they have to give e power minus 3 value, my dear. Sir, how you know e power minus 3 only will be given? I'll tell you. Because I'm the teacher, I know it. But look at this, you also can understand. If 1.5% of the items produced by the manufacturing units are known to be defective, look at this, my dear. N equal to, we have to find out for 200 items. P is equal to 1.5%. Am I right, my dear? Say loudly. So is it our M, my dear? That's what I said. I multiplied 200 into 1.5. That's it. 2 into 1.5. Is that right? M equal to what? 3. So what is e power minus 3 value? 0.0? Okay. Now, how the options are given? How many digits are given? Only 2 digits. How many digits are given? 2 digits are given. So, can I take only 0.05? Say loudly, man. Now, listen here. when this value is given in the question, you no need to find out this. Why? See, e power minus 3 value is given, so therefore this must be my m. Then why should I find out m again? See, actually in this case it is not given, that's what we are using it. Say yes or no? Now look at this. What exactly the question is? No? Is it x is equal to 0? Say yes or no? So what is it? E power minus m 3 power 0 by 0 factorial. The answer is 0.05 only. 13th question, sorry. For a Poisson variate, P of x is equal to 1 is equal to x is equal to 2, then what is the value of x? Listen here. 13th question. P of x is equal to 1 is equal to P of x is equal to 2 is given. What is the value of m? Am I right, my dear? This is what the question they asked you to find out. Answer is 2. Sir, without doing you got it. Yes, of course, I will tell you the shortcut later. Now, P of x is equal to 1 is equal to P of x is equal to 2. Now, apply the actual method. E power minus m, m power x divided by x factorial. Am I right, my dear? E power minus m, m power x divided by x factorial. Am I right, my dear? E power minus m get cancelled. M square and m get cancelled, only m. 2 factorial if you cross multiply is m equal to 2, my dear. Now, sir, what is the trick behind this, sir? I will tell you. To remember, if P of k is equal to P of k plus 1, then always k is equal to, sorry, m is equal to k plus 1. For example, P of x is equal to 3 is equal to P of x is equal to 4. What is the value of m? Say loudly. P of x is equal to 7 equal to P of x is equal to 8. What is m value? P of x is equal to 7 is equal to P of x is equal to 9. What is m value? Say loudly. No, nothing can be murdered. Is it consecutive number? 7 or 9 I said. 7 and 8 means 8 is k, 8 is m. 8 is not it's not consecutive. Another going to check pani paranga. Look at this. If P of x is equal to 1 is equal to P of x is equal to 3, what happens? Let me check. E power minus m, m divided by 1 factorial, e power minus m, m cube divided by 3 factorial. Cut. So is m equal to 6? Sorry, m square equal to 6. What is m equal to? Root 6. Oh. Okay, next. Only for consecutive numbers the trick to be applied. Now listen here. If 1% of an airline's flight suffer minor equipment failure, of course, minor equipment failure comes under Poisson distribution only, right? If 1% of an airline's flights suffer a minor equipment failure in an aircraft, what is the probability that there will be exactly 2 such failures in the next 100 such flights? So, will it comes under binomial or Poisson? Say loudly. Poisson. Fine. Tell me what is m is equal to here? What is m is equal to? Say loudly. Why m is equal to 1? N is what? 100. What is p is equal to? 1 by 100. So what is m equal to? 1. Very good. What is the question? What is the probability that there will be exactly 2 such failures? Exactly 2 such failure means they ask you to find out P of x is equal to 2. What is it? E power minus 1, 1 power 2 by 2 factorial. Tell me what is the answer? 0.184. Now listen here. If for a Poisson variable x, f of 2 is equal to 3 times f of 4, what is the variance of x? Look at this. F of 2 is equal to what? 3 times f of 4. Am I right? It's a Poisson variable, it is clearly given. So they ask you to find out variance. Variance means m. So tell me what will come? E power minus m. What is e power minus m is? M only. Correct? M power x divided by 2 factorial. Am I right, my dear? Is equal to what will come? 3 into e power minus m, m power 4 divided by 4 factorial. Cut, m square. So by cross multiplication, 4 factorial. Is it 24? Divided by 2 into 3 is equal to m square. So is m equal to 2, my dear? That's it. M is equal to 2. Shortcut lang. Okay, next. Now set C problems. Ninth sum. This question was asked 2-3 times. Little lengthy question. Let us solve for practice. X is a Poisson variate satisfying the following conditions. 9 times P of x is equal to 4 is equal to 90 times P of x is equal to 6 is equal to P of x is equal to 2. Tell me what is it, my dear? 9 times P of x is equal to 4 is equal to plus 90 times Am I right, my dear? It's a Poisson variate is given. So 9 times. Tell me what is the formula? E power minus m, 4 power, m power 4 divided by 4 factorial plus 90 e power minus m, m power 6 divided by 6 factorial e power minus m, m power 2 divided by 2 factorial. In each and every term, do we have e power minus m common? Do we have m square in common? Say loudly. So can we remove both? Let us remove e power minus m and m square from both. So tell me what will come? 9 m square divided by 24. Do you all agree, my dear? Because, yeah? The right side loud mein liya. Next step, 90 m power 4 divided by 720. Here what is it? 1 by 2. Three times, 8 times. How many times? 8 times. Am I right, my dear? Say yes or no? Now, LCM is 8, cross multiply that, what you are going to get? 3m square plus m power 4 is equal to 8 by 2, what exactly it is? 4. So therefore, m power 4 plus 3m square minus 4 is equal to 0. Is that right, my dear? Is it like quadratic equation? 4 ones are 4, plus 4 minus 1 will come actually. So when you do it, m square plus 4, m square minus 1 equal to 0. So what is factorization? Okay. So what is m square plus 4 equal to? 0. M square equal to? Discard this because imaginary number you will get. Next, m square equal to 1. What is m equal to? 1. NP is finite now. N is positive, P is positive, NP must be positive. So m is equal to what? 1. What is m is equal to? 1. What they ask you to find out, my dear? Find the P of x is less than or equal to 1. Which is 1 minus P of x is equal to 0. What is e power minus 1? What is e power minus 1? 0 point? So this question is actually what you know? Time consuming question. I am very sorry. Hey, correct only, na? Less than or equal to 1 you said? Correct தான போட்டுருக்கேன் என்ன இப்போ ஐயோ more than correct. Sorry, wait. I did a mistake. P of x is less than or equal to 1 means they ask you to find out P of 0 and P of 1. P of 0 and P of 1. So what is it? E power minus m power 0 by 0 factorial, e power minus 1, 1 power 1 by 1 factorial. Actually 2 times e power minus 1. Please find out. Seven three. Next, look at sum number 11. Fine, 10 also I will do. First 11 I will do 11 and 12, after that I will come to 10. A renowned hospital usually admits 200 patients. What is it, my dear? A renowned hospital usually admits 200 patients every day. 1% patients on an average require special room facility. On one particular morning, it was found that only one special room is available. What is the probability that more than 3 patients would require special room facilities? More than 3 patients would require special room facilities. Such a big sum. But only by reading the last line, we can get to know what exactly it is. I told you, e power value given means from that m I can find out. Actually, from this question, the first 3 lines, now based on 3 lines, we need to find out the m value. We need to find out the m value. Can you please tell me what is e power minus 2? 1353. This value will be given as soon as you complete the question. This value has to be given. This value has to be given. By using this, what do you come to know? Sir, m is 2, sir. I ignore the first 3 lines. What is m equal to? 2. I don't know what is there in the first 3 lines. From this, I can find out m equal to 2. What is the last line? More than or equal to or strictly more than? More than 3. Am I right, my dear? More than 3. Is that right? What is more than 3? 3 or more. Any number can come. Instead, what I do? 1 minus P of 0 plus 1 plus 2. Am I right, my dear? Less than 3 I will take. Less than 3 I will take. Hey, plus 3 also will come. Am I right, my dear? What is opposite of more than 3? Less than or equal to 3. And hereafter we have to proceed the question. I will proceed. Wait. Now, let me read the question. A renowned hospital usually admits 200 patients every day. So, what is n equal to? 1% patients on an average require special room facilities. Okay. On one particular morning, it was found that only one special room is available. By using this condition, I have to find out the value of M. So total how many patients? 200. What is the percentage? So therefore, what is M equal to? 200 into 1 by 100. What is it, my dear? 2. This way, from the 3 lines, this is what we have to find out. But when this is there, why should I read the 3 lines? Correct, na? This is there means what? Why should I read the 3 lines? Directly I can get it. Now, 1 minus, tell me what exactly will come? Two power 0 by 0 factorial plus e power minus 2 2 power 1 by 1 factorial, e power minus 2 2 power 2 by 2 factorial, e power minus 2 2 power 3 by 3 factorial. Take e power minus 2 outside. 1 plus 2 plus 4 by 2, 2 plus 8 by 6. Am I right, my dear? Okay. 1 minus, what is e power minus 2 value? 0. 1 plus 2 plus 2, 5. 40 plus 8, 48. Correct only, na? Oh, 38. So, which is nothing but 19 by 3. Can you please find out 0.1353 into 19 by 3 and minus 1? Zero point what? Approximate value only will get now, because e power minus 1 to whatever. Okay, approximately you will get this answer. Option A. A car hire firm has 2 cars which is hired out every day. For example, I am having 2 cars and I am giving it for rent. The number of demands per day for a car follows Poisson distribution. Fine. With mean 1.20. With mean 1.20. So M equal to 1.20. What is the proportion of days on which some demands are refused? Now, I have got 2 cars and it is for rent. It's a rented car. I have to give it for rent. In spite of that, I'm refusing some orders. From when I will start refusing the order? When I get more than 2 orders. When I get more than 2 cars, I will start refusing the order. Am I right, my dear? I will start refusing the order. Say yes or no? So, is it nothing but P of x is more than 2, my dear? Say yes or no? So, if I get 3 cars, so 3 orders, definitely I will start refusing it. 5 orders, I will start refusing it. I can just service only for 2 cars. P of x is more than 2. What is my P of x is more than 2? 1 minus P of 0, 1, 2. Am I right, my dear? P of 0, 1, 2. Is that right, all of you? P of 0, 1, 2. Now, e power 1.2 is given. Can you tell me what is e power 1.2? 3.3? But we don't want e power 1.2. We want e power minus 1.2. Tell me what is e power minus 1.2? 0.301. Now, 1 minus e power minus, see, here also I am going to get e power minus 1.2. Here also I am going to get e power minus 1.2. Here also I am going to get e power minus 1.2. Can I take e power minus 1.2 outside? So, what exactly will come? X 0. M is what? 1.2. 1.2 whole power 0 by 0 factorial plus 1.2 whole power 1 by 1 factorial plus 1.2 whole power 2 by 2 factorial. Can you please simplify this, my dear? Point? Answer is 0.1 to 1. What is the option? If you ask me frankly, if Poisson distribution comes now, actually it's a scoring part. But because of the understanding level now, we are actually ignoring it. Actually it is scoring one. What and all to be found out? M value is given in the question only. Only what to be found out? X. That too from the last line you will come to know what is X. More than, less than or equal to, if you know, problem is solved. Actually it is scoring. Okay. For your information, both these questions came in the exams. So, now that's all with our Poisson distribution, my dear. That's all with our Poisson distribution. Poisson distribution is over. So, discrete distribution, both are over. I want you to solve additional question bank problems for discrete distribution. Okay, I want you to solve additional question bank distribution on your own.